In this video, we're going to look at aggregating our data, try and reduce the multiple observations we have on people in order to, in some cases, just make the data more precise, more sensitive, take an average, sort of like repeated measures of a particular outcome variable to make it more reliable. And so we find aggregate under the data heading and then down here under aggregate. And there's something called break variables, and a break variable is what is it that you want to be able to separate out. So, for example, we want to have all our data by ID. The other thing we do is we want to have all our data by last refractive status. We're using the vision data set, and it has these features to it. Now, we want to average over visit. We don't really want to have each visit recorded. We want to take the mean visit, but actually we're going to do this in a couple of ways. One is we're going to look at the mean visit, that's over all visits. And we're going to look at the first visit. So we're going to go into first, continue. And then also a function that we want to click, and we're going to do visit again. And let's take a look at the last visit. So we have mean, first, last. Those are the functions we have available. You can see there are a number of functions that we can use. Mean, median, sum, standard deviation, all of these are things that we can aggregate by. All right, so we have actually, when I think about it, we don't really do this, although it doesn't hurt. But what we're really wanting to do is look at the mean spherical equivalent, the first spherical equivalent, and the last spherical equivalent. I'm going to get rid of these visits because that's not really what we're looking for. Okay, we could also look at any of these variables. All the different variables you want to look at, you can stick in here. You can look at, say, IOP. It defaults at the mean for a numeric variable. It defaults at the first, well, here ethnic is coded as a numeric. Let's see, I don't know that I have any character variables in this data set, but all right, so that's how we're going to aggregate. So we're going to have, for each subject in this data set, we're going to have their last refractive status. Now, it turns out that this is a between subject variable, so really breaking by this is it will maintain it without looking at it, but there's only one category here. Anyway, you can see if you were doing something where you had different groups, like let's say you had different conditions. Let's say you were doing a study where you had blue light and brightness. So you'd put in blue light here, and if it was all within the same person, you'd have for each individual, you'd have their blue light, no blue light, bright, and dim light. So you'd have 4 observations for each ID. In this case, we're only going to have 1 because their last refractive status is the same across all the visits. All right. Next thing very important to do is we have to create a new data set. And I always start my aggregates with an ag at the beginning to say I'm aggregating. And then I often will say what the break variables are. In this case, it's ID and last ref status. So that's the name of my data set. And the file's already sorted. I can click that. I don't have to. I mean, it'll sort it, but it's already sorted, so it's not going to take any time. Another thing you can do is see how many cases you have for each person. We'll create a new variable called endBreak. Alright, now you can see here it's done that. When we go to look at our output, we now have a new data set called Untitled. And here it is. So subject 1500 was an extreme mild. Before, subject 1500 had 6 variables because they were followed for 6 visits, the baseline, in 5 more years. And here, that's reduced to 1, and it has the mean, the first spherical equivalence, and the last. So they started out at minus 0.01, and they ended up at minus 3.6. Then we have a bunch of emmetropes. Notice only one observation. Their beginning, or their mean, their beginning, and their end. You'd see pretty much, well, this guy didn't go down, but most went down from their first to the last. And that's their mean IOP over time. We didn't really do much with that. And this is how many observations are within each one. So that's how you use data aggregate. So when you, let's say you wanted to test for normality, and what you want to do, if you had, let's say you had 2 conditions like blueness and brightness, you would split the file by blueness and brightness, and then by blue and bright, and then you would do a QQ plot for each value. Here we only have one value for each one, so we're going to do our QQ plot just based on that number. We're going to look at IOP and spherical equivalence, and here we have our plots. And spherical equivalence, not exactly super straight, but kind of tails off at the end up there. It's kind of straight-ish up to that point. Our IOP is also, looks like it might be kind of skewed. So we can further look at these to understand what's happening by going into frequencies and spherical equivalent mean, IOP mean, charts, histogram, get rid of the individual table, okay. So this first one does kind of tag, it's skewed a little to the left, but it's not really all that bad. IOP also has a little bit of a skew. We could just get rid of, trim it, do a trimmed mean and kind of get rid of it, or this amount of skew with this number of subjects, since we have quite a few subjects, is not going to have a big impact. Now if you only had a few number, like say 9 or something, then the skew could kind of negatively impact your mean. But that's what we are looking at. This is also good if you're going to do an analysis of covariance, except I don't think I have enough. So let's look at what we would do for that. Let's go to a graph, legacy. So we need to say we wanted to check our baseline values with our follow-up. So in this case, we're going to do a scatter plot I'm going to do a simple scatter, and we are going to do the first as the baseline X and the final visit as the Y, and we're going to set our markers by refractive status. Let's see what we get. So we have a graph that looks like this. Let's double click on this. And we want to fit lines separately for each of our levels of refractive status. And the assumption for analysis of covariance says all these lines are equal. And this guy looks like an extreme hyperope is not really very parallel. All the other lines aren't too bad, although the extreme myope is pretty flat down here. But it doesn't have very good range of values either. None of them really do. So if we didn't use the extremes, we would meet the assumption of analysis of covariance. If we're going to include the extremes, we might want to include an interaction term between the baseline, the first visit, and refractive status, an interaction term in our analysis. Otherwise, I think we're pretty good to go. Again, you want to, if let's say you were doing a study and you just had a few things, what you want to not do is have multiple observations in these groups. Each one of these dots represents one unique, different subject. Let's say you had 9 subjects and you were measuring them a number of times. Well, for each condition, let's say we were doing that blue and brightness study, if you would have 4 lines, a blue dim, a blue bright, a non-blue dim, and a non-blue right, and you would check the interaction. Say you were looking at, you had 9 subjects, you're looking at choroidal thickness, you would want to only have 9 points for each of your 4 conditions. So you would draw this graph, have 4 lines, 9 points per line. So that's basically how you aggregate. The reason why you aggregate is so that you can do these tests and reduce the number of observations you're looking at each time. So that, for example, if you had region or some region for choroidal thickness, then you would not want to have multiple observations within a person. In doing the QQ plot and the test for analysis of covariance, the assumption is that your observations are independent. If you're using the same subject multiple times, you don't do that. So that's pretty much it. That's how this works.